Hey, how's it going? Hopefully good. I hope you're having a good day. I'm G, and welcome to the Stuff You Should Think About podcast, where I answer everyday questions about phenomena and objects. Today, we're talking about where math came from. And I mean, way back before anybody would have called it this grand, polished thing, before proofs, before formulas on a whiteboard. Before some poor student was staring at homework like it had personally offended him. Math started as a tool, pretty practical one. At the beginning, people needed to count. That's really it. How many sheep do we have? How many jars of grain? How many days until the river floods? If you're farming, trading, building, or trying not to starve, numbers matter fast. So the earliest math wasn't abstract in the modern sense. It was tied to hands, goods, fields, seasons, and the sky. Mesopotamia is one of the big places to look here. In that region, people developed systems for recording numbers because daily life demanded it. Trade had to be tracked. Taxes had to be counted. Storehouses had to know what was coming in and going out. And astronomy mattered too, because if you're trying to organize a calendar, predict seasons, or time rituals, you need patterns. You need counting that stays reliable. One of the really interesting things about Mesopotamia is that their number system wasn't built the way ours is. They used a base 60 system, or sexagesimal. That sounds fancy, but the simple version is they counted in groups of 60 instead of groups of 10. And weirdly, that old choice is still hanging around in our lives. 60 seconds in a minute. 60 minutes in an hour. Circles divided into 360 degrees. Ancient habits are sticky, apparently. They also work with fractions and tables because practical math needs shortcuts. If you're dividing land, sharing goods, or figuring out quantities, whole numbers won't carry you very far. So this wasn't baby math. It was organized, useful, and already more sophisticated than people sometimes assume. Egypt gives us another great example. Egyptian mathematics was deeply connected to administration and building. Land had to be measured, especially after the Nile flooded and wiped away boundaries. That matters. If a field line disappears, somebody's going to argue. People have always been people, so measurement became important, and geometry grew out of needs like that. The Egyptians also used fractions in practical ways. If you're dividing bread, grain, labor, or payments, fractions aren't optional. They're survival. And geometry showed up in construction too. Not geometry as a classroom exercise, but geometry as a way to make things stand, fit, and line up. What I like about this early period is that math feels very physical. You can almost see it. A scribe marking quantities, a trader checking accounts, a surveyor stretching a cord across the field, a priest or observer watching the stars and trying to make sense of repeated motion. It's numbers with dirt on them, numbers with weather and arguments and deadlines. But here's the important part. Once people build reliable methods for counting, measuring, and calculating, those methods can start to drift away from their original problem. A technique used to divide grain can become a general rule about numbers. A method for measuring land can become a question about shape itself. That's the first step toward abstract mathematics. So math didn't begin as a detached world of symbols floating in space. It started because people needed to do stuff, keep records, mark time, build things, share things, predict things. And then, slowly, those useful tricks became ideas you could study for their own sake. That's where the story gets really good. So now we get to a major shift. In Greece, mathematics started changing from mainly, here's how to solve this problem, into here's why this works at all. And that's a huge leap. It's one thing to know a method gives the right answer. It's another thing to prove it. Greek mathematics is often associated with geometry, and for good reason. What stands out is the emphasis on logical argument. If one statement follows from another, and the one follows from another, you can build a chain that doesn't depend on guesswork or habit. That proof-based style became a defining feature of mathematics. It turned math into not just a toolbox, but a way of reasoning. And I think that's the moment where math starts sounding more familiar to us, not because the symbols were the same, they weren't, but because the attitude was. Don't just calculate it, show me, convince me, prove it. At the same time, other parts of the world were pushing mathematics forward in different but equally important ways. In India, one of the biggest developments was the use of zero and the decimal place value system. This is one of those inventions that feels so normal now that it's easy to miss how powerful it is. The value of a digit depends on where it sits, and zero holds place. Without that, calculation gets clunky fast. Seriously, try imagining arithmetic without the decimal system we use now. It's like trying to carry groceries with your elbows. You can maybe do it, but why would you want to? Indian mathematicians also made major contributions to algebra and trigonometry. Algebra at its core is about working with unknowns and relationships in a general way. Instead of solving only one concrete problem, like this pile of grain, this one field, you can describe a whole pattern. That's another move toward abstraction. Trigonometry, meanwhile, becomes essential for understanding triangles and angles, which matters in astronomy and measurement. Then, Islamic scholars played a critical role in this long chain. They preserved earlier mathematical knowledge, translated it, studied it, criticized it, and expanded it. And that matters because knowledge doesn't survive automatically. Somebody has to copy it, teach it, organize it, and build on it. This period is especially important for algebra. In fact, the world itself comes from Arabic. Scholars developed systematic ways to solve equations, making calculation more general and more teachable. That's a big deal. A method you can explain clearly can travel. It can be learned, adapted, improved. And from that world, we also get the idea behind algorithms, step-by-step procedures for calculation. That word traces back this history too, which is kind of wild because now when we hear algorithm, we think phones, feeds, search results, all that kind of stuff. Because the root idea is much older, a reliable method for getting from problem to answer. Once math was tied tightly to life, math became more structured, more profitable, and more universal. The Greeks sharpened proof, India transformed notation with zero and decimals, and advances algebra and trigonometry. Islamic scholars preserve and extend their tradition, especially in algebra and calculation. Different routes, same overall movement. Math becoming a language for general truth, not just immediate tasks. Then things speed up a lot. Early modern mathematics reshaped science by giving people better ways to describe motion, change, space, and scale. 3 developments really stand out: analytic geometry, logarithms, and calculus. Analytic geometry connected algebra and geometry. Instead of treating shapes and equations like separate worlds, it showed they could describe each other. A curve could be written as an equation could become a picture. That bridge is incredibly powerful because it lets you move between visual thinking and symbolic thinking without losing the thread. Logarithms change calculation by making hard arithmetic easier to handle. Before electronic calculators, simplifying long computations mattered a lot. Like, a whole lot. If you're doing astronomy, navigation, or engineering, cutting down the labor of multiplication and division can save time and reduce errors. It's practical, but it also opens doors. Easier calculation means bigger problems become manageable. And then there's calculus, which is one of those subjects people either love or side-eye forever. But the core idea is beautiful. Calculus gives a way to study change and accumulation. How fast is something moving right now? How does a quantity build up over time? Those questions are everywhere in physics and engineering. Once calculus appears, science gets a much stronger mathematical engine. By the 19th and 20th centuries, mathematics expands again, and in some directions it gets wonderfully strange. Non-Euclidean geometry showed that geometry didn't have to follow only the old familiar rules of flat space. Set theory asked basic but powerful questions about collections, infinity, and how mathematics itself is organized. Logic became central too, with mathematicians digging into the structure of reasoning and what can be formally shown. This is the part where math stops looking like one big road and starts looking like a whole city. Different neighborhoods, different tools, different questions. Some of it is still closely tied to the physical world. Some of it gets very abstract. But even very abstract ideas can come back later and transform technology. And that's our world now. Computers depend on mathematics. Coding depends on mathematical logic and structure. Physics leans on mathematical models to describe space, motion, energy, and more. The systems we use every day, networks, encryption, scheduling, search, graphics, data processing, none of that happens without math sitting underneath it, doing quiet, relentless work. I guess the way I feel about it is this. Math is one of the clearest examples of humans building something practical and then discovering it can become almost unimaginably deep. It starts with counting sheep and measuring fields. Then it grows into proofs, algebra, calculus, logic, computer science. Same long story, just a bigger and bigger tools. And honestly, that's kind of comforting. The most abstract mathematics on earth still has roots in people trying to keep track of things, make sense of patterns, and not get lost, which feels pretty human. That's it for this episode of The Stuff You Should Think About. I hope your day went the way you wanted it to go, and I hope the math feels a little less like this sealed off mystery box now. We'll get into more of these big human-made systems in future episodes. See you next time.